of the time it won't be. You need a factor. For the number in the front. Though you will be get those, but you factor, and then if the x plus 2 and the bottom has an x plus 2, you need to cancel out the x plus 2's. Okay. So when you have zeros, you cancel out common factors. So to find the zeros, or the also known as the x-intercepts, that is when g of x, which if you look up here, that's the numerator. I cannot spell today. E-R-A-T-O-R. Numerator. So you set the numerator equal to 0. So every factor that's left over in the numerator, set them equal to 0. That gives you your x-intercepts. Okay. We would say that the function is undefined when h of x, or the denominator, is set equal to 0. Because you can't divide by 0. So if you have a 0 in the denominator, your function is undefined. If I were to try, if I put in one of these in my calculator, like on number 1, and I were to look at the table, where x is -2, it would say error beside of it. It's undefined there. So let's go to an example. The x-intercepts, or I'm going to use the word zeros. So first of all, everything is factored. We have an x minus 1, an x plus 2, and an x minus 3. There's nothing else I could do to factor those. Are there any common factors that I can cancel out? There's not. I have an x minus 1 in the top. I do not have an x minus 1 in the bottom. So nothing else to cancel out. So to find my zeros, I set everything in the numerator. In this case, there's only one thing. X minus 1 equal to 0. So x equals positive 1. So this right here only has one x-intercept at 1. Okay, it's undefined. I set the bottom factors equal to 0. So x plus 2 equals 0, which gives me x equals -2. And x minus 3 equals 0, which gives me x equals 3. So this one, if we think back to our horizontal asymptotes that we learned Monday and practiced yesterday, this one has a degree of 2 in the denominator, which is greater than the degree of 1 in the numerator. So it does have a horizontal asymptote at 0. And it kind of looks, if you look here at the graph, it looks like my blue line goes on 0. That's because the calculator only has so many pixels. It can only be so accurate. It really doesn't hit 0. These undefined actually turn into vertical asymptotes, which we'll talk about in our next lesson. Okay. All right, so number 2, I have a 2x plus 5. That does not factor down anymore. X minus 7, a 3, and an x minus 1. Nothing to cancel. So my zeros are where the numerator is equal to 0. So if I solve this one, I would get 2x equals -5 x equals negative 5/2. And then x minus 7 equals 0. So x equals 7. And then undefined, 3, you don't have to set that equal to 0. If I had a 3x on the outside, that would be different. But just a plain number, you don't set equal to 0. Only what has the x. So all I do is x minus 1 equals 0. Any questions? Again, this is going to be just more memorization. You have to know if it asks for the zeros of a rational function, that's where the numerator is set equal to 0. I will add those to the Quizlet. That's why it's so important that regularly you're just going through that Quizlet and trying to memorize just these concepts, these things that you just have to know. Okay. So number 3, these are not factored. Okay. X squared minus 1. That is a difference of squares. If you see a difference of squares, the little light in your brain needs to be going off. X squared is a perfect square. Any exponent that's an even number is a perfect square. 9 is a perfect square because it's 3 times 3. 4, 9, or 1, 4, 9, 16, 25, 36. Those are perfect squares. So that top factors into x plus 3, x minus 3. Difference of squares. You take the square root of each, your a, you get your a and b, and then you have a plus and a minus. The denominator, something's missing there. That should have a number. Let me go look on my computer. It didn't. It's supposed to be plus 10. So we need two numbers that multiply to be 10 and add to be 7. What are they? 5 and 2. So x plus 5, x plus 2. Does anything cancel out? They do not. Okay. So my zeros, x plus 3 equals 0. So x equals negative 3. And x minus 3 equals 0. So x equals positive 3. It's undefined when the denominator is equal to 0. So if I set both of those factors equal to 0, we get negative 5 and negative 2. Number 4, my numerator. What does that factor to? What multiplies to be 12 but adds to be negative 7? Negative 3, negative 4. X minus 3, x minus 4. Now, the denominator, it's not a difference of squares. It's not subtraction. It's not one of these normal trinomials. However, it has a GCF. Notice how both terms have at least an x squared. That's your GCF. So x squared, leaving us with x plus 5. So sometimes you'll have a GCF. None of these other examples have we had one. Nothing cancels out. So my x-intercepts or my zeros, we set the numerator equal to 0. And my function is undefined when the denominator is equal to 0. So I will need to set x squared equal to 0. That's different from number 2. This one just had a number in the front. This one actually has an x. So you would take the square root of both sides to get x equals 0. And then x plus 5 equals 0 gives us x equals negative 5. Any questions? Now we're going to do inequalities, which is this is what we did with polynomials. All right. So number 1. Make sure the inequality has a 0 on one side. So it's like less than 0, greater than 0. Make sure you have a single rational function. So make sure all you have is one fraction, greater than or less than or equal to 0. And step 3, factor everything. Okay. We're going to do just like we did on the front. We're going to factor everything, and we're going to set every factor top and bottom equal to 0. You're going to find all of the x-intercepts, all of the undefined spots. And those are the numbers that are going to go in our number line. Okay. Now, unlike polynomials, if we have like a greater than or equal to, typically we would always use brackets for those. However, or what a bracket means, it means that number actually works in your function. That number would make it true. But if we'll see this when we get to an actual example. If there was a number that was undefined, one of our denominator numbers, those always get parentheses. Because if I plug in a number that makes my function undefined, it doesn't work in there. And that's something we'll use. I don't know how picky a test question would be on that. I doubt that you would have a test question where everything was the same except one had a parenthesis, one had a bracket. Again, there's never been a test, so I don't know that for sure. But I would think that would be the case. Okay? And then we're just going to test the value. We're going to pick test values just like we did before. All right. So number 5, everything is already factored for us. So if I set each factor equal to 0, I've got a 2, a negative 6, and a 3. You don't have to show x minus 2 equals 0. You don't have to do that. Okay. So I'm going to have 3 numbers. A negative 6, a 2, and a 3. Now something that I have found that is helpful, I'm going to circle the ones that were on the denominator. Those are my undefined numbers. If I need to write a negative 6 or a 3, we need to make sure those get parentheses, not brackets. Okay. So, a test number. Let's see. I will just pick negative 10. That's below negative 6. A number between negative 6 and 2, I'll test with 0. Between 2 and 3, 2.5. 3 and up, I'll just use 5. So I've just picked some test numbers. So if I plug in a, and we're just, all we care about is do we get a negative or a positive. A negative is less than 0, a positive is greater than 0. So if I do negative 10 minus 2, am I getting a positive or negative? Negative, right? Over negative 10 plus 6. That's negative. Negative 10 minus 3 is negative. So I would have a negative number divided by a positive number. Is my answer going to be positive or negative? Negative. Okay. Alright, if I plug in 0, 0 minus 2, negative. 0 plus 6, positive. 0 minus 3, negative. So a negative number divided by a negative number is positive. If I plug in 2.5, 2.5 minus 2 is still positive 0.5. 2.5 plus 6 is positive. 2.5 minus 3 would be negative. Be negative 0.5. So a positive number divided by a negative number is negative. If I plug in a 5, 5 minus 2 is 3, that's positive. 5 plus 6 is 11, that's positive. 5 minus 3 is positive. All that's going to give me positive. So my inequality is specifically asking for the intervals or the sections that are greater than or equal to 0. That's asking for the positive. So we've got these two. Okay. So my intervals are between negative 6 and 2. That's one of them. All right. The negative 6 is going to get a parenthesis because it was an undefined number. Okay. The 2 is going to get a bracket. It's not an undefined number, and my inequality had the equal to part. So I can give it a bracket. Okay. And then my other interval that works is from 3, that needs a parenthesis because it was one of my undefined, to what? Infinity. And infinity, regardless of anything, always gets a parenthesis. And so this, and I would prefer you to get used to writing. Remember that little U symbol in between. Probably not. So let's try another one. Number 6, this one is not factored. X squared minus 4 is a difference of squares. What does that factor into? X plus 2, X minus 2. The denominator is a trinomial. No number in front of the x squared. So we need two numbers that multiply to be 25 and add to be negative 10. Yep, x minus 5, x minus 5. So the numbers that I'm going to plug into, that I'm going to put on my number line, are going to be a -2, a +2, and a 5. You don't, since we would have the same number, you don't need to do it twice on your number line. So -2, 2, and 5. And I'm going to circle the 5 just to remind myself that was one that was on the bottom. That has to have parentheses. The only reason I circle it is just for a reminder. Okay. And so pick your test numbers. -5, 0, 3, 10. You got to plug your test numbers into all 4 of those. -5 plus 2 is negative. -5 minus 2 would be a negative number. -5 minus 5 would be negative. And negative again. So this would be a positive over a positive, which is positive. If I plug in 0, I've got positive. 0 minus 2 would be a negative number. Minus 5 would be negative and negative. So this one is a negative over a positive, which is a negative number. If I plug in a 3, I would have 3 plus 2 is 5. That's positive. 3 minus 2. 3 minus 5 is negative. 3 minus 5 is negative. Positive over positive. Positive. And if I plug in 10 to all of those, I've got a positive, 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 positive. That's all positive. So they won't always, a lot of times they alternate. That's not guaranteed to always happen between positive, negative, positive, negative. All right, so you do have to test out every section every time. So this one's asking for what's less than 0. So that would be this section. Since there's no equal to part, I'm going to use parentheses on everything anyway. So -2 to 2. So these are all the numbers between -2 and 2 are the only numbers I could plug into this to make it less than 0. That's what I'm saying here. And if you had your calculator on a question like this, you could type it in and look at the graph to see which ones are, less than the x-axis, but this is how to do it really without a calculator. Okay. I went back to giving you some easier ones, really. All right, so number 7. That numerator does have a GCF of 4. It is important that you always test that out, because if I would have had an x plus 2 in the denominator, those would have canceled. So you always need to go ahead, Even if you think it's not going to change anything, go ahead and factor out a GCF, because it might. So I've got a -2 and a -5 on my number line. Make sure you put the -5 first, because it's less than. You go in order, least to greatest. I will use -8, -3, and 0. That's my test numbers. Okay. So if I plug -8 in, well, we've got this +4. I'm just going to go ahead and put a positive for that +4. If that was a -4 on the outside, you would need to make sure you count that negative. That would be part of your function. So a positive, and then -8 plus 2 is negative. -8 plus 5 is negative. A negative divided by a negative is a positive number. All right, we have a +4 times a negative, and -3 plus 5 is actually positive. So a negative divided by a positive is a negative. We have a +4, a +2, and a positive. That's all positive. Oh, and I forgot to circle my -5. So the interval I'm going to use is just this middle one, because it's asking for what's less than or equal to 0. That would be negative numbers. So I do have to use a parenthesis, because that one was on the bottom. It doesn't work. And then -2, that one can get a bracket. Almost done. All right, number 8. Everything is factored. So I've got a 1, a -2, and a 2 to go on my number line. I'm really bad at spacing these. So I might use a -5, a 0, 1.5, and 5. Okay. All right. So I have -5 minus 1. It'd give me a negative if I plug that in. A -5 plus 2, that's a negative number. But what do I get if I square a negative number? You actually are going to get a positive there. And then -5 minus 2 is a negative. So a negative divided by a negative is a positive. 0 minus 1. Positive squared is still a positive over a negative. That would be positive. (1.5) minus 1 is a positive. Positive squared is positive. 1.5 minus 2 is going to give me a negative. positive divided by a negative. It's a negative. And then, alright, we got 5 minus 1 is 4. Positive, 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 positive. So my question was asking me for what's greater than or equal to 0. Those are the positives. Notice how I have 2 positives right in a row. If this middle number is included, like it would be a bracket, we don't have to make 2 separate intervals. We can actually just make one big one from negative infinity up to 1. Okay. If negative 2 had been circled, or if the equal to part wasn't there, if it was going to be a parenthesis, you'd have to make them separate. Okay. And then also from 2 to infinity, that one gets a parenthesis because it was one of the undefined numbers.
When we write this out, will we have them with the break and then like beside each other?
Like if you were just writing your answer, probably what you would do something like this. And that's what you as your final answer. If you just write them separate, that's okay too. Try number 9. Alright, so on number 9, the only number that needs to go on your number line is a positive 1, because you didn't have any x's in the numerator. So this one does not have any x-intercepts. Okay. So we've got like 0 and 2. So we would have a positive 1 on top, and 0 minus 1 is positive. A positive 1 over a positive would be a positive. So both of these intervals give me positives, which is what my question was asking for. However, I do have to make them 2 separate intervals because the 1 itself is not included. So the 1, having 2 separate intervals and having the parentheses distinguishes the fact that 1 is not included. Every other number, if I plugged in any number in this except for 1, I would get something that's greater than or equal to 0. So we have negative infinity to 1. And then 1 to infinity would be your answer. Now the last one is just the picture of the graph, which probably would make more sense if I had put that at the beginning, but it's okay. Why is it? There we go. Alright. So we're looking for where this function is less than or equal to 0. So this is everything that is below the x-axis. But also touching the x-axis too. So that would be this section right there and that section right there. Now you're going to want to put negative infinity to negative 1. That is not correct. Your interval or your x values. What's the far left that this section is going to go? This little piece. What? Negative 3. Notice that asymptote right there? That's acting as a barrier. This section right here does not go any farther left than negative 3. So I would have negative 3 to stop there at 1. And that negative 3 is going to get a parenthesis because it's an asymptote. It's not actually included. I don't know how picky they would be. I would think not that picky. And then from 2 until it hits this asymptote at positive 3. So that's where it's less than or equal to 0, below the x-axis. Okay, greater than 0, so anything that's above the x-axis would be this section right here. That's above the x-axis, and those sections. Those are above the x-axis. So this section right here starts at -1 and goes to 2. And the equal to part wasn't there, which is why I did not put brackets. Now this section, we can assume that it goes forever. This section does go left forever. So it starts at -infinity and it stops. It's not going to go any more to the right than that asymptote at -3. And then this other section here, the far left is at +3, and it continues to infinity. I messed up. It's infinity. Okay. Now number 12 is asking where it's greater than or equal to 1, which is this horizontal asymptote. That's just these two sections right here. So those two.